Hi guys, thanks for tuning into CMTEQ channel in this series of tutorial on Raspberry Pi and Arduino interfacing. In the previous tutorial, we demonstrated how we were able to basically control the LED that is attached onto the Arduino pin 12 from the Raspberry Pi. So when I run this Python script here, basically we are able to send instructions. So if I hit on, right, so I'm sending an instruction and we're turning the LED on, and if I hit another instruction off, we'll be turning that LED off. So it is a good application, it is running. But now in this particular tutorial, so if this is your first time watching this tutorial, please maybe watch the previous one so you can catch up to the material we are covering here. Now in this tutorial here right now, we want to improve from here and basically write some kind of a real-life application that will be some sort of a street light control system. So we want an Arduino maybe attached to a street light and taking some light measurement for us, okay? And when the Arduino get the light level, then the Arduino will send the instruction to the Raspberry Pi command center and tell the Pi, well, we want to basically turn the LED on. So because the light level is low, then the Pi will send the instruction back turning the LED on. And if the light level goes above a certain threshold, then the Arduino will send another instruction to specify that the light level have gone up, and the Raspberry Pi will return by sending instruction to turn the light off. So it is a bi-directional integrated communication system that we can implement. So this is some kind of a real-life application, but obviously you can use this kind of system for any sort of thing that you want to create for yourself. Now, so if you stick around, this is basically what you're going to be adding to your tools of Arduino and Raspberry Pi skills. In the meantime, if you like this tutorial that I am doing, please subscribe and give a thumbs up. CMTEQ channel will highly appreciate your support. So the first thing I'm going to do is to create two variables. Now the variables that I'm going to create will basically manipulate the delay system. Now here we were basically just calling the delay function and pause everything for 1 second, right? Now this is wasteful. It's wasting the CPU just to add there for 1 second. So I'm going to use a state machine so that we can basically pause without delaying anything. So to do that, I'm going to create two variables. So the first variable will be of type unsigned. So unsigned long, okay, and I'm going to call this variable a very familiar name that will be sampling delay. So this is basically the delay that I will be waiting before I take a sample. So that is to measure the light. Then I will create another variable, also unsigned long, and this one will be called previous, okay, previous lux sent. Okay, so every time I take a light measurement, I send it to the Pi. So this will be that previous lux sent, the time spent that I'm sending that lux. So I'm going to give this value what? The millis function. Good. Now the rest of the stuff here, this variable is still fine. We're using the same port there. We can attach a relay here onto the Arduino or any kind of device we want. It's still going to operate. So the setup function, nothing changed. Right now we have here this function. We are using the receive data. So let's just comment it out. Okay, let's comment it out and create a new function. So the new function I'm going to create will be called street light control, right? So street light control. Now this function does not exist, so I'm going to come here and create it. So void street light control. Good. Now we need to write some code into this function here. So the first code we're going to write here is basically to do some kind of a checking. So we're going to do a timing comparison here so that we can take a sample. Okay, basically a light measurement. So I'm going to create another variable of type unsigned long also, and this variable I'm going to call him millis now. So millis now is basically will be millis right at this particular point. Okay, and then I'm going to call now my if statement to do the comparison. Now inside the if statement, I'm going to basically do my subtraction operation, so that will be millis now. Now millis now minus what? Minus the previous lax sent. Now this result must always be greater or equal to sampling delay. Okay, once that is satisfied, we know we're always going to wait for 1 second. Okay, so once this is true, then we execute the if statement. Okay, now in the if statement, we can then say the previous, okay, the previous lax sent. Okay, so this is now, this time now must be now updated to be equal to millis now. Right, what is happening here is the first time we execute a street light control. So we've got a variable millis now that will be equal to millis. Then we do this subtraction here. So this millis now remember, this millis now here is going to be greater than the previous lax millis that we recorded here as soon as the Arduino booted. Okay, but we must ensure that this result here, okay, must be greater than or equal to the sampling delay, which is 1000. Once that is satisfied, then we take the previous lax sent value, which was previously equal to that value of the millis at that time. We then give it to the value of millis now at this point, and then we do our sample. Now every time we come back, this must be satisfied, so it must always be, so this result must always be greater than 1000 before we can execute, greater than equal to 1000 before we can execute a sampling. Now to do the sampling, I'm going to create another variable and I'm going to say int lax. So this variable is basically going to store the light level. Okay, so I now need a function that is going to do light measurement. So I'm going to call this function light measurement. Right, so I don't have a function that can do light measurement for me for now, but I have to create it as well. So what we're going to do is this light measurement function is going to return some kind of a light level value that must be stored to variable lax. So now this is what we're going to send to the Raspberry Pi. So to send it, we then call serial.println. So we take the serial.println and then we pass the parameter lax. So this is what is going to the Raspberry Pi. Okay, now before we can actually attempt to compile this, let's first create the new function here. So that is going to be the function that will be doing the light measurement. So this function must return something, okay, so which means it's of type integer. So I'm gonna say int light measurement, just ensuring that it is exactly the same light measurement. Okay, for now it's not taking any parameter. Now just for the sake of demonstration right now, I'm not going to write any complicated function here that must read a value of a phototransistor to measure the light level. I'm just going to make use of a trick here, so that basically I'm going to call the random function. Okay, so the random function will basically just generate some random lax level for us. So to do that, I'll create another variable int, I will say lax value. Okay, now lax value must be equal to what? Equal to random. Now inside the random function here, you have to specify the ranges for your lax level. Now just to make it some kind of a real life application, let's make the lowest lax level to be 10, okay, and the highest lax level to be 500. So basically when the light level or the lax value fall to about 10, then the light should come on, and when it goes above 500, then the light should turn off. Okay, then we need to return this value. Okay, so we must return lax value. Right, so this lax value is the value that will be returned by this function and passed to lax variable and that will then be sent via the serial print line. Now let's go ahead and upload this code into our Arduino board. Okay. Alright, so now we can go ahead and pull out the serial monitor so that we can actually just monitor what's being sent. We know that it is supposed to be generated by the random function that is apparently giving us some fake lax value. Here it is, so we're getting some random data which is a lax level. Now this is being actually sent to the serial line, and the Raspberry Pi here should be able to capture this data. Okay. And then once the data fall below a particular level, we should be able to turn this LED on. And if it goes above a certain threshold, the light should turn off based on the instruction here. So on our serial Python script here, we can basically make use of the receive data function that I've demonstrated in the previous tutorial. So what I'm going to do is I'm going to comment out the send data function and enable the receive data function. So inside the receive data function here, we must be able to basically check the serial data, right? If the serial data in waiting is greater than 0, that means there is something in there. We're just going to pause for a moment, then we're going to actually just store that data, right, and read it and decode the data and strip the end of line, and basically we can print this data. So let's just run this for now and see if we can get something going on onto our screen. The Arduino is connected. Okay, so here it is. So the function, basically we exited the while loop, right? So we exited the while loop and then we just printed one time. So we only printed one time. The Uno is basically sending here the value of 157 lakhs. Now, as you can see that this only executed one time, so I'm going to just modify this function and make it run forever. So to make this function execute forever, I'm just going to say while true, okay, and I'm going to now call the if statement here. Okay, so now what we have to do now here is to move all these print under this if statement. That way it is going to run forever while the while loop is true. Now let's try to execute it, assuming we're not going to get any error. Okay, there is no error. So now you can see that we are getting random values, okay, of lax, okay, light level coming from the Arduino. Okay, so I'm going to stop it. Now what we have to do here is to basically execute another if statement here. So what we're going to basically now do here is to say, well, if what we are reading here, the my data, right? So if my data is basically less than what's the light level that we want to check. So let's say if it's less than 20 lakhs, okay? So if it's less than 20 lakhs, we need to turn the light on. Okay, so I'm just going to make another print here. So in this print here, I'm going to say the light level is low, right? So if the light level is low, what then do I have to do? Now, if the light level is low, what are we going to do? We basically want to send a command to the Arduino to say that, well, the light level is low, you need to turn the street light on. So basically I'm going to copy this line here, okay? So then this line of code here, as data, I need to write. So what I need to write is data, but I do not have data. So I have to declare another variable that I'm going to assign the command that I'm sending. The command is going to be on. Now if I do not want to declare another variable, I can basically just write it right here. Okay, so this will be the command on. Okay, but always include the end of line. So that will be \n. Right, now this here is basically ready to be sent to the Arduino. So the Arduino will be receiving this on command if the light level is less than 20 lux. Okay, now the next thing is to do another check, and this check is to check else if, right? So that is else if my data, right, is greater than what? Greater than 300, let's say 300 lux. So if the lux level is greater than 300 lux, then we're going to call this same function here. And what we're going to now do with this function is we're going to write a new instruction, and that will be the off instruction. Okay, and this off instruction then need to be sent to the Arduino, and the Arduino must turn the light off when you receive this instruction. Now we can basically just run this and see what result we're going to get. Okay, so let me just run this. Okay, Arduino connected. Well, we've got an error here. Something is not right here. Let me just close here. What is it saying? Error not supported between instances of string and int. Where is this? Line 63. Okay, line 63. My data is a string. Well, the fix here is very simple. We just need to cast it. So I'm just going to cast it to an integer. So basically we're going to cast the whole read line here to an integer. Okay, so basically this will now become an integer. So let's run it again. Hopefully we're not going to get the same error again. Okay, we're still getting an error this time around. Where is the error? Okay, that's one here. So let's just chop this off because we do not need it. Once again, let's run. Okay, right. Well, we're not printing anything, but it seems like the program is basically running. Right, so I'm going to stop this program and just modify slightly the instruction here. So the first time here, so when the light level is below 20 lux, we say, well, the light level is low. So here I would like to print the value that we are actually getting. So I'm going to string and then take my data, right, and put it there. Okay, so it will be light level is low, so lux is equal to this particular value. Then the next stage will be if the light level have gone high. So I will then also take this print statement, and then I will basically, let's put it before we can actually send the instruction to the Arduino. So here we're gonna say the light level is high. Right, so if the light level is high, and we need to send the instruction to turn the light off. Right, now we can go ahead and give it a run again. Let's first clear the screen here and give a test run. Okay, Arduino connected, the light level is high. So this is a lux that we're getting because all of this is actually above 300 lux. That is what we're printing. Okay, now the light level is low, we get that. So we are supposed to send the instruction, we are supposed to send a command when we're printing that. Okay, so now but the light is not being turned on or off when we are actually reading this lux value. So what we have to do here is we must be able to receive this command here from the Arduino side. Now what we can do here is there is already a function here that say receive data, so we can just copy this function here because we already implemented everything based on the on and off level. Right, so what we have to do here is basically to call the receive data function. Okay, now the receive data function is coming right after we sending the lux instruction to the Raspberry Pi, and the Raspberry Pi is going to return a command based on what it's going to read, and we're going to now execute a receive data function. Okay, now here we're already handling everything. So first thing here, let's write it into the Arduino. Okay, it is being written. Now it's loaded. Let's go ahead and run this Python script again and see what's going to happen here. Okay, the light level is high. Whoops. Value error invalid literal for int with base 10. Where is this? Off. So it seems like we are actually reading something. We are reading something which is off. We are reading off, but this is a problem. So the Arduino is actually trying to send data back. Yes, it should send data, but here the lacks. Now let's see if we've got another. Oh, okay. Well, we've got another serial print here, so we do not need this serial print, and it is actually sending the message. Okay, the message from the Pi, which is actually these high, the off and on. We're sending it back, and that cannot. Actually, it is a string, and it is a problem because here we concatenate netting to an integer, so it's a problem. So let's write it again. While serial print line there is now disabled. Now let's go and test again the code. What is happening? Arduino connected, lux level 383. Yes, the light is off. Okay, the light is off, no problem. We have to wait until the lux level is gonna go below 20. Okay, there it is below 20 and the light turns on. Right, it is working and it goes again above, and the Pi again turn the LED off. Okay, now it seems like we have something that is working here. There is a bi-directional communication we are able to control, but obviously we can tweak and change this program so that it can do what we actually want it to do. So this random function here is basically generating numbers that are higher than 300 most of the time. So let me pause here, and I'm going to just change here, okay, so that we can just see some more activity. I'll put it 200. Okay, now let's try again and see if we're going to get some more actions going on here. Okay, well, we're still off because we're still above 200. Yes, we are still above 200. Okay, so the random numbers are being generated mostly on a high side. There we go, 18. Okay, the LEDs indeed turns on and it goes off again. So these random generator generate mostly high numbers. So I'm going to increase here and make it 100. Okay, then I make this 300. Now let's try again so we can get more actions going on here. Okay, there we go, the LED should turn on. Right, okay, there it goes off as soon as we go above the threshold. Then we are waiting for the next time the light level will go low so we can turn the LED on. There it goes low. Okay, there it is low. There we go, it goes high again, and the LEDs turn on and off. Right, as you can see, it is indeed working. The program is working. So this is it, guys, for this tutorial. If you learned anything and you find it very interesting, please subscribe to CMTEQ channel and give this tutorial a thumbs up. Stay tuned for more exciting Raspberry Pi and Arduino interfacing tutorial. Until next time, cheers.